Welcome, Code Slingers. In this tutorial, we're going to be covering the stack data structure. A stack is a collection that allows you to pile elements one on top of the other. You can only add or remove from the top of the stack. Therefore, the last element added will be the first one to be removed, and thus it follows a last in, first out order, or LIFO or LIFO. A little mnemonic that I used to apply back when I was first learning this was the word stack life, and then just replace the E at the end with an O. This way you will always associate that a stack implements a last in, first out order. If you're anything like me and you need a tangible example, the best way to visualize this is with a pest dispenser, where you can push candy into the dispenser and the candy remains organized in this stack-like manner. And the very last candy pushed in will be the very first one to be popped out. You can continue popping candy from the dispenser, and at the end, the first candy pushed in will be the last one to be popped out. And obviously, when there are no elements left in the stack, it is set to be empty. Let's now dive into a coding example for the implementation of a stack. In this case, I'll be using Java, but a stack's behavior is always the same no matter what language you use to implement it. So even if you're using a different language, this tutorial will still be relatable. So here, I want to make sure that I import the Java util library. And now I'm going to declare a stack of integers. I'll just name it stack with a lowercase to keep it simple. If you're using Java 8 or later, you don't need to re-specify the type on this side of the instantiation. This is also known as diamond notation. After my stack's been declared, I'm going to go ahead and add the same values from our pest dispenser example, and for that I'll use the push function. Now our stack has been populated with these values 1 through 6. Now, to pop the values, I'll use a while loop. So while not stack is empty. So what I'm going to do here is I'll declare an integer variable. Let's just call it value. And I'll store that value that was just popped from the stack. And I'll go ahead and print this value to the console. Let's save and run. And here we see our values being popped in a top to bottom order, where 6 was the last value pushed and the first one popped out. Let's now talk about the peek command. Let's say that you want to know what is the current value at the top of the stack without actually removing it. That's what peek is for. So in this case, I'll print a line that says the value at the top of the stack is, and then do a stack peek. So when I run this, I see that the value at the top is 6, but it wasn't actually removed from the stack. Again, the values aren't actually removed until I reach this stack.pop line. So when are stacks mostly useful? There's several cases to use them, but a pretty common one is to determine if the parentheses of an equation are properly balanced. That is, that all the open parentheses in the equation are properly closed. As you know, a closing parenthesis closes the very last parenthesis that was open. In other words, the last open parenthesis is the first one to get closed, and then the second to the last, and so on. That's exactly a stack's behavior. In this second equation down here, we see that only the last open parenthesis has been properly closed, and then we have these open-ended parentheses at the beginning that are never closed, so this equation is not properly balanced. So for this problem, I've implemented this Boolean function named Isbalanced, which takes in an equation in the form of a string. So I've declared a stack of the type character for the characters of the string. And what I'm gonna do is I'm gonna iterate through every character of the string. And if the current character equals an opening parenthesis, I'm gonna push that to the stack. However, if I encounter a closing parenthesis, first I'm gonna check that the stack's empty. If it is, then I'm gonna know the equation is not properly balanced because I'm attempting to close a parenthesis that was never open in the first place. So I'm just gonna go ahead and return the false. However, if the stack's not empty, I'm going to pop the last value or parentheses added to it. After I'm done iterating through the string, if the equation is properly balanced and every parenthesis open was properly closed, then the stack should be empty by now. So I'm gonna check for that once again, and if there are any remaining values in the stack, i.e. opening parentheses that were never closed, then I'm also going to return a false. Otherwise, I'll return true. So up here, I have three hard-coded equations. In the first one, we see that both parentheses open were properly closed, so this one is properly balanced. In this next one, we see three opening parentheses and only one's closed, so it is not balanced. And finally, this one has a bunch of closing parentheses, which that right there is already wrong. Then 5 times 2, and then 2 opening parentheses, so this is definitely not balanced. So then I'm going to call the isBalanced function, passing each of these equations and printing out the result to the console. So when I run that, we see that indeed we get a true for that first one being properly balanced, and the other two are false. So hopefully this tutorial has painted a clear picture on how stacks work. If you enjoyed this tutorial, smash that like button. Don't forget to subscribe, and most importantly, share this video with your peers so there can be more code slingers like us out there. See you next time.